And so you see that there's 3 capital letters, and you go magnesium must be 2+. Well, it's always 2+ because where it is on the periodic table. And nitrate on my cheat sheet tells me it's NO3 minus. The reason why its molecular formula or chemical formula is like that is because I needed 2 lots of the nitrate in terms of charges to match the 1 magnesium 2+. So I use brackets to say I need 2 lots of that whole thing. For naming, it's really easy. Rule number 1A says you don't change the ending to "ide", you just name it as is if you see a polyatomic ion. In my next one, this is the first time we've encountered 2 non-metals. Okay, so I need to use my covalent naming system, which says I name the element on the left-hand side, which is already done, nitrogen. And because there's 2 of them, I say dinitrogen. And then I'm over to 4 oxygens, and the word that we use for that is tetra, like Tetris, 4 things. And you don't say it like this. A little subtle thing is if you get an A and an O and stuff, you generally just drop the A. So it's tetroxide. You want to get that wrong. By the way, close enough's good enough phonetically is pretty much how science goes, because a lot of people are English second language, and science is pretty generally hard. So even all the way up to the HSC, phonetic spelling gets you over the line, but no harm in trying to be proper. This one we got SR, which is strontium, just down here. It's in group 2, so strontium is going to have a charge of +2. Phosphate is up in your cheat sheet area. You should start to see the relationship between all this. Name the metal first: strontium, phosphate. Not a transition metal. This one's easy: metal, non-metal, magnesium oxide. Magnesium is in group 2, oxygen in group 6. 1-to-1 ratio in terms of charges. Iron, transition metals. So I go iron, I go boom, gonna have to put in some transition metals, and I go fluoride. And I go, how am I supposed to work out the charge of fluorine? I could do a reverse cross and drop. Or the other way I can do it is I go fluorine's minus, and if I have 2 of them, it's going to make me 2 minus it. Iron must be 2+. Right, bit of algebra. In this next one, we got sodium. Sodium carbonate. Okay, 3 capital letters, gave it away. Sodium is in group 1. Carbonate is on your cheat sheet. This one's got the transition metal copper and so I'm going to put in that, and then hydroxide, which is a polyatomic ion. I needed 2 lots of that hydroxide, and OH minus is one of them, so copper must be 2. Again, I could do the reverse cross and drop, take that 2 up there and that. Okay, just wiped out the copper. It's actually 2+. And in this last one, I just threw it in to use a unfamiliar polyatomic ion. And we've got nickel. Nickel is actually a transition metal. I actually can't remember where nickel is from memory. Shows you don't actually have to need to memorize it. I do know it's a polyatomic ion. There it is. Nickel. Sorry, I said polyatomic ion. I meant transition metal. So I got a nickel, and I don't know its charge yet, but I do know sulfites one, SO3. Note that it's SO3, not SO4. So a lot of people first time would be like, oh, sulfate, that's one of my common ones I need to do. It's actually sulfite. It actually has the same charge. So it's 2 minus. If they come together in the same ratio, nickel must be 2+. Okay. By the way, nickel spelling is slightly weird for people. EL. Nickel 2 sulfite. Right. And you'll see a lot of these ionic ones. They're more common than covalent, and covalent's fairly easy because they kind of give it away with the prefixes. So if you can remember mono, di, tri, tetra, penta, hexa, hepta, octa, you won't go higher all the way up to your 12.